We have discussed electric drive extensively in this series. In the Liebherr T282C, the diesel-electric haul truck whose rear wheels are powered by AC motors. In the Komatsu WE2350, the AC drive truck whose individual wheel torque control prevents wheel spin with millisecond precision. In the Letourneau L2350, the wheel loader, whose electric wheel motors trace their heritage directly to R.G. Letourneau's pioneering work. Electric drive in mining equipment is not new. It has been present in various forms for decades. But the current generation, high-power AC motors, and sophisticated inverter electronics is categorically more capable than earlier DC systems. The Komatsu WE2350 is the answer Komatsu has developed, the largest electric wheel loader in Komatsu's production range. The wheel loader duty cycle is more demanding. The crowd phase involves rapid transitions between high-torque, low-speed operation and zero-speed stall conditions. The carry phase involves acceleration and turning with a full bucket load. The dump phase requires precise controlled motion at low speed. This variable duty cycle creates thermal management challenges for electric drive systems that haul trucks do not present to the same degree. Managing motor and inverter temperatures without reducing performance is one of the central engineering challenges of the WE2350's development. Specific solutions in motor sizing and control algorithm design make the WE2350's electric drive sustainable through the demanding cycle. This machine represents the beginning of the transition from diesel to electric drive across an entire category of industrial machines. This will have implications for mine operating costs, carbon emissions, and the economics of clean energy that extend far beyond the WE2350. The Komatsu WE2350 has an operating weight of approximately 227,000 kilograms and a bucket capacity ranging from 30 to 44 cubic meters depending on configuration. The machine's dimensions place it in the ultra-large wheel loader category, competing directly with the CAT 994K and the Letourneau L2350. The electric drive system uses 4 AC traction motors, one at each wheel, producing a combined output for productive wheel loader operation. Each wheel's motor is independently controlled by the inverter system, providing the same individual wheel torque control that the 9D80E haul truck uses. This control is valuable during the crowd phase, where traction conditions at each tire change rapidly as the machine pushes into the pile. The diesel engine in the WE2350 drives a generator that produces the AC power for the traction motors, a diesel-electric architecture. The engine is sized for the loader's duty cycle, which has a different average power demand than the sustained climbing of a loaded haul truck. The thermal management system addresses duty cycle challenges. The AC traction motors use liquid cooling to remove heat generated by electrical losses. Liquid cooling provides higher heat removal than air cooling, allowing motors to be compact while sustaining full power through the crowd phase. Inverters also use liquid cooling, maintaining temperatures to prevent derating across the full range of ambient conditions the WE2350 operates in. The regenerative energy recovery capability is one of the most interesting features. During the crowd phase, traction motors can generate electricity. This regenerates energy from deceleration rather than dissipating it as heat. During the return phase, regeneration is again available. Recovered energy is fed back to the generator bus, reducing the diesel engine's load and effectively improving fuel efficiency. Fuel efficiency improvement from regeneration is more modest than in haul trucks, but it is measurable and consistent over thousands of cycles. It contributes to a fuel efficiency advantage over conventional mechanical powertrain loaders, adding up to meaningful operating cost savings. In field conditions, engineers confirmed their analysis was correct and were surprised by the magnitude of one specific improvement. Individual wheel torque control's prevention of wheel spin produced a fuel efficiency benefit larger than the engineering team had predicted. Wheel spin events in conventional machines interrupt forward progress, requiring the operator to back off, recover, and reapproach the pile. This recovery time added significantly to cycle time. The WE2350's wheel spin prevention eliminated both the energy waste and the time waste. This discovery has influenced how Komatsu calculates productivity benefits and strengthened the business case for the WE2350 in difficult ground conditions. The WE2350's integration with Komatsu's Comtrax Plus fleet management platform extends the complete system visibility that Komatsu's mining equipment strategy provides. In operations that deploy WE2350 loaders alongside Komatsu haul trucks and excavators, the fleet management platform captures operational data from all machine types. Loading cycles, haul cycles, fuel consumption, and machine health are all captured in a single integrated view. This integration enables specific productivity optimizations that mixed-brand fleets cannot achieve. When the system sees both loader and truck data simultaneously, it can identify loading time versus travel time imbalances. It can suggest adjustments that improve the system's balance and alert management when truck positioning is extending loader cycle times. These system-level optimizations become visible only when the complete fleet data is integrated. The WE2350's autonomous operation capability, building on Komatsu's AHS technology platform and electric drive controllability, is an active development area. The crowd phase of wheel loader operation is one of the most challenging sequences for autonomous control. It requires real-time response to changing material conditions, traction feedback, and bucket fill assessment. Komatsu's progress builds on decades of experience with autonomous haul trucks and specific sensing technology for wheel loader applications. The L2350 heritage provides the WE2350's development team with decades of field experience operating large electric wheel loaders. Knowledge of failure modes, maintenance requirements, and operational practices from the L2350 has been incorporated into the WE2350's design. This expertise is embedded in the operational recommendations that Komatsu's mining support teams provide to WE2350 customers. The Komatsu WE2350 is most transformative in applications where conventional wheel loaders experience frequent wheel spin. This is where the electric drive's individual wheel torque control produces its largest productivity advantage. Soft ground, wet haul roads, and variable material density are conditions where the WE2350's electric drive advantage is most clearly expressed. In copper mining, particularly high-altitude Andean operations, ground conditions can be compromised by precipitation, frost, and variable material characteristics. The WE2350's traction advantages translate into higher productive utilization and better consistency of truck loading across varying conditions. Mine managers report productivity improvements relative to conventional mechanical drive alternatives that exceed the engineering model's predictions. In Australian iron ore operations, where seasonal rain creates variable traction conditions, similar advantages have been documented. Maintaining productive crowd speed where conventional machines would spin provides a significant production gain across a fleet of loaders. In coal mining, where material density is lower and wheel spin is less frequent, the WE2350's advantages are more modest. Fuel efficiency from regeneration and reduced mechanical maintenance from the electric drive are the primary benefits in these conditions. This application-specific performance profile defines where the WE2350 is most competitive and where conventional alternatives may still win. Komatsu's strategy focuses on high-traction demand applications where the machine's engineering strengths are most fully expressed. The WE2350 represents the beginning of a transition that will eventually affect every large wheel loader on Earth. The transition from diesel mechanical to electric drive is coming as surely as it came to the haul truck category. The WE2350 is the first demonstration that electric drive technology works at the performance levels mining operations require. The path to battery electric or fuel cell electric will follow the same trajectory as in haul trucks with improving technology. The AC drive system is directly compatible with battery or fuel cell power sources. The motors and inverters require no modification. When that change happens, it will occur from a position of proven technology rather than from scratch. What the WE2350 represents is Komatsu's commitment to being at the forefront of the mining equipment electrification transition. The company that standardized diesel-electric haul trucks is making the electric wheel loader the next standard technology. Engineering heritage, customer relationships, and technology investment are all aligned toward this goal. The WE2350 is the beginning of that alignment's expression in product form. The beginning is always the most important part. This completes the first section of our series, 25 machines telling a story about engineering at the boundary of what is possible. These are the machines that built the modern world. Next, we move from land to sea, where the challenges are equal in scale. The pioneering spirit awaits, a machine that lifts oil platforms from the sea floor like a person picking up a coin.